Hello everyone and welcome to the first video in my series on Semantic Kernel.
My name is Ali Issa
and I work as an AI lead at a company based in Sweden. It's my job to innovate and experiment with cutting-edge technology within AI, such as Semantic Kernel. So I'm really excited to share with you what I have learned about this powerful SDK. If you find this content interesting, please subscribe to the channel and hit the bell icon to get notified about our future videos. Let's dive in. Today's agenda is as follows. I will start by describing what Semantic Kernel is and what it's used for. Then I will walk you through a simple example of how to connect it to Azure OpenAI GPT-4o and execute a prompt. In future videos, we'll dive deeper into more advanced features and use cases, but today we'll start with the basics. So what is Semantic Kernel? Semantic Kernel is a lightweight, open-source SDK designed to simplify the integration of large language models into applications. Whether you're working with C#, Python, or Java. Semantic Kernel abstracts away much of the complexity. It spares you the need to keep track of constantly evolving AI APIs, as Semantic Kernel handles the calls to the underlying AI models. This abstraction is crucial given the rapid pace of innovation within the AI field. Furthermore, Semantic Kernel can be used to connect to various AI models. This includes models available in Azure OpenAI, and Hugging Face. This flexibility ensures you can leverage the best AI tools available based on your needs. Semantic Kernel is also highly extendable. You can add your own custom functions, tailoring the framework to meet your specific needs. This flexibility is a significant advantage for developers looking to customize their AI applications. All these capabilities make Semantic Kernel an excellent SDK for building AI agents that can answer questions or automate complicated processes. It was, in fact, designed to power products such as Microsoft 365 Copilot and Bing Copilot. Now let's move on to the practical part. We'll walk through a simple example of how to connect Semantic Kernel to Azure OpenAI GPT-4o and execute a prompt. First, let's go over some prerequisites. To be able to access and use large language models available in Azure OpenAI, you need to obtain an API key. Please note that calls to Azure OpenAI API will incur costs. Alright, after that you need to launch Visual Studio Code, navigate to the terminal and type the following command to create a console application. .NET New Console -OSK Introduction. Next, you need to navigate to the application directory and then add the Semantic Kernel NuGet package by typing the following command in the terminal. .NET add package Microsoft.SemanticKernel --pre-release. Alright, now we are good to go. Let's have a look at the code. Let's walk through this simple project step by step. First, we have our necessary imports. These give us access to the tools we need, including Semantic Kernel and the ability to load environment variables. And here we have our main method. We start by loading our environment variables using .envload, which reads my .env file and loads the variables into our application. In this file, I have defined the API key, the endpoint, and the deployment name of my GPT-4o model in Azure OpenAI. Next, we declare new variables and assign them values from our environment. This gives us local variables containing our Azure OpenAI configuration details. After that, we do a quick check to make sure all our necessary variables are not null or empty. Now, the exciting part. We create our kernel and use the add Azure OpenAI chat completion method to connect to the chat services. As you can see, the arguments in this method is the deployment name, the endpoint, and the API key. With that done, the kernel is now ready to interact with GPT-4o. Next, we define a prompt, which is the text instruction we give to GPT-4o to generate a response. In this case, the prompt is, tell a funny and playful joke about how you, GPT-4o, are better than Llama 3.1, the latest large language model released by Meta. After that, we invoke the prompt and await the result. Finally, we output the result and have exception handling. So let's run this code. And there you go, we have got a joke back. And it says, why did GPT-4o challenge Llama 3.1 to a duel? Because it heard llamas are great at spitting facts, but GPT-4o is better at bite-sized humor. Well, I think we could all agree that GPT-4o won't become a comedian anytime soon. Alright guys, that was it for this video. I hope it spurred your interest in Semantic Kernel and showed you just how simple and powerful it is. Make sure to subscribe for more videos on Semantic Kernel and other exciting AI topics. Leave a comment below with your thoughts or any questions you have. Thanks for watching, and I'll see you in the next video.